Hello, all students. कैसे हैं आप लोग? I'm sure everyone is doing very well. Today is the second lecture of the week. As we all know, these are virtual science sessions where we talk about simulations. We take up two interesting topics every day on a Saturday and a Sunday, which is weekends. And this is brought to you by Homi Baba Foundation in association with Scholarlab. It's always a pleasure to interact with all of you live during our sessions and something which I really look forward to throughout the day. So, today again, as we all know, we are going to start off with two interesting simulations. The simulations which we are taking today, one of them is based out of, I could say, physics, uh, and one of them is based out of bio. Both simulations are kind of interesting. At the same time, they are information based. So, whenever you might have seen that whenever there are simulations which are information based, if you have the availability of simulations and real life applications, it actually becomes really interesting. Correct. uh, the first one which we are going to do is actually going to be about combustion, right? And as you all know, combustion involves a lot of heating. It's a little difficult for us to actually conduct it in the actual school lab. And even if we are conducting it in school labs, generally आप लोग देखोगे कि आपके टीचर्स जो हैं वो इस एक्सपेरिमेंट को करेंगे, आपको मोस्ट स्कूल्स में हैंडल नहीं करने देंगे, बिकॉज ऑब्वियसली इट इज डेंजरस, राइट? इट इज फॉर योर ओन सेफ्टी, एंड दैट इज व्हाई मेनी स्कूल्स डोंट अलाउ फॉर यू टू हैंडल दिस. बट इन सिमुलेशंस वही तो अच्छी बात है, ये है कि आप इन सिमुलेशंस को कितनी भी बार कर सकते हो. दिस इज completely safe, and also you will find out what are the observations, what are the things which have to be understood from the simulations very, very easily, right? So I think that is the whole point of doing the simulation. The first one which we are going to see is combustion, right? और combustion के simulation में जो main objectives हैं वो भी हम देख रहे हैं. The main objective is to explore and understand the behavior and characteristics of fire and flame. The following questions will be answered through the simulation. What is the need of fire to appear and stay stable? That is very important, right? Fire को appear होने की जरूरत क्या है और उसे stable रहने की जरूरत क्या है? How do you control fires and what is the characteristics of a flame, right? uh, for each of these objectives we have ample examples which are relevant, right? We also will have separate simulation tab for fire and flame and provide several experiments to understand their behavior and characteristics. We'll also run these experiments provided in the simulation set. We'll observe, analyze, and interpret the results of this experiment. So this is basically what we are going to do over here. Okay, so let's start with the experiment. Just a second. I hope everyone can see my screen. Seems like there is some issue with the screen sharing. I will just quickly share my screen again. Hopefully you will be able to see it now. Just a second. And done. All right. So guys, as you can see, we are inside the simulation of fire, flame, and quiz. So let's go to fire. In fire, we have four drop downs. One is fuel, oxygen, heat, and controlling fire. Okay, so let's go to fuel first. So we're going into the first tab and we're going to see कि जो हमारे various aspects हैं, various चीजें हैं, how do they behave when we talk about combustibility, right, and non-combustibility. So can they be used as fuel or not? ठीक है. अब फ्यूल जैसे किसको यूज कर पाएंगे? हम उस चीज को यूज कर पाएंगे जो जब हम उसको फायर दे, व्हेन वी स्टार्ट द फायर, दे शुड बी एबल टू बर्न बाय गिविंग आउट एनर्जी. कोई ऐसी चीज जो हमें एनर्जी दे, उससे हम फ्यूल मान सकते हैं. बट अगर कोई ऐसी चीज जो एनर्जी प्रोड्यूस नहीं कर रही है तो वो फ्यूल माना नहीं जाएगा, वो कंबस्टेबल नहीं होगा, राइट? चलो एक एग्जांपल लेते हैं, जैसे फॉर एग्जांपल वुड, right? You can see so many different examples we have which we can find. So you can see that जब हमने ऑक्सीजन में इसको हीट अप किया तो एनर्जी निकल रही है, the wood is getting burnt. इसका मतलब ये है कि there is heat energy which is coming out. इसका मतलब wood is combustible. अब हम कोई और भी चीज ले सकते हैं, देखिए आप देख सकते हो कि these are solids, these are liquids and these are gases. That's how they are divided in our textbooks also. So let's say for example we take stones. Okay, अगर मैं stones लूं और मैं फायर के ऊपर रखूं, अब क्या हो रहा है? Nothing is happening. There is no heat, there is no flame which is getting developed, and that is why stones will be classified as non-combustible. Let's also take another example. Let's say paper. If you're taking paper, putting it on the flame, what is happening? The paper is getting burnt, right? It means paper is combustible. We can use it. We might not be able to use it as fuel. The reason is because the amount of heat which is produced is very less, but definitely it is a combustible substance which is going to be uh, classified as solid. Next, we have coal. Coal again is absolutely combustible. In fact, you know that there are coal engines which are used, करेक्ट एंड उन सारे इंजन में पहले तो बहुत सारे ट्रेन्स भी कोल के ऊपर चलती थी. सो इसका मतलब ये है कि कोल डेफिनेटली एक कंबस्टिबल चीज है, एट द सेम टाइम फ्यूल की तरह भी हम उसे यूज कर सकते हैं. देन देयर कम्स द नेक्स्ट वन व्हिच इज कैंडल. Definitely candle is something which you light up, it is going to be used as fuel. Why? Because it produces so much of energy once it is used. Then we have petrol and kerosene. Let's say we take petrol. I'm sure everyone knows petrol is a certified fuel. We use it in automobiles, we use it in so many different places. So definitely petrol is combustible, right? So this is petrol, which is combustible. Let's go to kerosene and see if kerosene can be used. Absolutely, kerosene is used as fuel and it is absolutely combustible for sure. Then let's see matchsticks, which is again a solid, and see if matchsticks can be used as fuel. The answer is yes. Why? Because they are combustible, but can they be used as fuel? Not really, right? Because the amount of heat which is being produced is very less. Okay, that's the reason why. So would matchsticks be combustible? Answer is yes. Would they be used as fuel? Answer is no, right? Okay, now let's say LPG. LPG is liquefied petroleum gas. We know this because we use it in our houses for cooking. And because it is used for cooking, obviously it is something which is going to be combustible. At the same time, it can be used as fuel as well. CNG, we all know it is used in cars, it is used in vehicles. Again, a very good source of heat and very good source of fuel, and therefore it is classified as fuel. करेक्ट. सो होता ये है कि जब हम लोग इतने सारी चीजें हमारे आसपास देखते हैं, एंड दे जस्ट write it in the textbooks that okay, this is the first thing, this is the second thing, these are the things, but when you do it in a simulation, उस टाइम पे हमें ये और ज्यादा अच्छे से समझ में आता है, और आई वुड से बहुत और ज्यादा टाइम तक याद रहता है. करेक्ट. नाउ लेट्स सी द नेक्स्ट एक्सपेरिमेंट विद व्हिच इज विद ऑक्सीजन. तो हम क्या कर रहे हैं, हम एक we are taking a beaker which has oxygen. We are having a candle which has been that beaker has been put on it, and this is what has been done. Now what we're doing is we're putting another beaker right on top of it, and we are seeing something very interesting happening. The candle is kind of going off when you are putting it in this kind of a closed container. Now, why is that happening? Very simple. When you had put it in open containers like this, you were seeing that the candle was actually burning for a longer time. But when you're putting it in a closed container, basically anything which is burning under combustion requires oxygen to continue burning. Okay, because the central idea of combustion is that you have carbon reacting with the oxygen to produce carbon dioxide. Okay, and since this is a reaction, you need oxygen to actually have combustion going on. If you don't have combustion going on, if you don't have oxygen coming in, then it would not be possible for you to have combustion, right? Okay, let's see, there is another experiment which we have over here which is called heat. Okay, let's understand what is this experiment and what we have to do over here. So I'm going to put uh, two containers, right, on the two parts of a beaker. these are two beakers, and we have put on the Bunsen burner. And what we are basically trying to do is basically trying to see, oh, you see what happened here. There was a kind of a blast which happened over here, but over here the temperature is just keeping on rising, right? So the heat capacity of this liquid is very high. And because the heat capacity of this liquid is very high, you can see that it got burnt much later. Correct? It got burnt much later, but this container got burnt more easily. If you want, we can see this experiment once more, right? We just have to refresh this, and we can see this experiment once more. But the idea is that which of the two liquids is able to control and contain heat for much longer, that is going to be a better, source of fuel for us, right? And therefore, it was shown as the heat experiment. Next, we are going to see how to control fire. So you see there's a building on fire, and we have two options. One is to control it using water. The other is to control it using carbon dioxide, right? So let's see what happens if we control it using water. So we have our water tanker, and as you can see, I can actually just spray that water across in this entire place, and it is getting controlled. Somehow it got controlled. Okay, we still have some fire over here. So I'll just take this and point it in this direction. We can actually work as firemen when it comes to our simulations. Okay, so that's the case with fire, right? Now let's take the example of, let's say, carbon dioxide. So I'm going to go to electric wire, again, come back to this. Let's say if I use carbon dioxide, what happens? So we are having carbon dioxide, and we are putting it. Water was better than carbon dioxide in this case because of the volume and the ability to reach inner parts of the house, and thus bringing fire down, whereas carbon dioxide extinguishers can't be used effectively from safe distance, right? So when a building is on fire, it makes sense to put water, right? But what about electric wires? If you have electric wires which are, uh, have caught fire. Let's say if we take carbon dioxide, and if we start putting carbon dioxide, let's see if that can really help. So you see, what we've been able to do is we've been able to put off the fire, right, using carbon dioxide. And the reason why we're able to do this is because carbon dioxide, for wires, works slightly better. Uh, and the reason for that might be because it is able to give out more of these carbon dioxide. The more you give carbon dioxide, I think the more it works in our favor in case of electric wires. Let me just quickly take water and show you what happens. You see, there is an electric shock which has gone through. So fire in this case is extinguished by CO2. Water cannot be used for electrical equipments. Which factor is getting affected? Is it the oxygen supply or the heat? So the answer is that when you're giving water, okay, heat is first of all higher, right? And oxygen supply, you're giving oxygen supply because H2O breaks into H2 and O2. O2 is then going to support fire as well, right? So when it comes to carbon dioxide basically produces a layer on top of the heated place, because of which it becomes easy for us to cut the contact between the fire as well as the oxygen in the atmosphere. So that is why in this case carbon dioxide works much better. Okay, let's now go to flame and understand the different types of flames. And this is something which is very useful for us to get an idea of difference between flame and fire, right? We have seen all examples of fire so far. Now let's see the example of flame. So as you see, we've basically just switched off the light just to be able to understand the different types of flames, right? So you see, this is candles. You have Bunsen burners, your ovens. There is something called as a heater. There's a coal bricks which are kept, correct? And I can observe it from different sides like this. All of these classify as flames. Okay. Now let's look at candle flame. So we are taking this wick and we are actually, just going to have candles to be uh, observed. Observe the difference in height of the test tubes with respect to their candles. Observe how the temperature of water in each of the test tube changes as time goes on. So you see that in the first case, the height of the test tube is slightly more. It is slightly away from the candle. In the second one, the flame is actually just touching the test tube, right? So this is the situation. You see that this one is actually going ahead in temperature much more as compared to the other one, correct? Now this is going to 65 and I can fast forward it, and this is going to 70 and the other has gone to 70, other has gone to 60. Now let's understand what is the thing. The thing is that the hottest part is the tip of the flame, right? And the outer zone, if you see, the moderate part is in between, and the least hot part is at the bottom. The outer zone of complete combustion is blue in color. Complete combustion basically means that the oxygen in the air is reacting with the wax, and which has carbon and is producing carbon dioxide, and that is the outer zone. The middle zone of partial combustion, which we see as yellow, and the innermost zone is unburnt wax vapor, which is black. Okay. So this is why we have maximum combustion to happen in the outer part, and therefore you will see that a little far, if we are able to put the test tube will be more towards the outer zone of complete combustion, and that's why you will see that the temperature rises much faster as compared to if the test tube is kept near the middle zone or the lower zone, right? So this is the difference between a flame. This is the difference between a fire. Now let's look at quiz. As we all know, quizzes are an important part of our simulations. जैसे आप लोगों को पता है कि there will be 5 questions. All of these questions are going to be based on the topic which is being given. And what we tend to do is we tend to see whether you have understood the relation between the topic as well as the uh, curriculum. Okay, ये जो 5 questions हैं in the quiz, they keep on changing. So there is something called as randomization which we have included, and in this case of randomization, what happens is that you can keep on changing the questions. So that is something which is really valuable. Okay, ये 5 questions होते हैं, and at the end of every question, uh, at the end of every 5 questions, you get to see your score, and then you can go back and also see the explanation for those questions as well. Okay. Next topic for today, the second topic which we are going to see is the topic on conservation of plants and animals, right? And let's first see why there is need for conservation of plants and animals. So you can see this is a topic which is there in our textbook, and it is really long and really boring. And the reason for that is because there are so many examples from different parts of the country, different parts of the world. And at Scholar, we are trying to see how we can make this more interesting for you, right? And for that, what we've done is we've actually mapped out those examples on the globe itself. So if you want to see a particular example for a particular country, say for example from India, if you want to see an example, I can just click on this and I'll be able to read about what is the example given. So in Ghaziabad, India, Ghaziabad is the second most polluted city in the world after Bhutan, with an average air quality index of 106.6. So you can understand that this is the consequences of pollution, right? Of irresponsive behavior from the point of view of the population, and in fact the whole human race, correct? uh, So you will see that one of the major negative on-site effects of soil erosion is the loss of soil fertility status, leading to decline in productivity. Correct? The social and economic cost of soil erosion is most evident in India, where 0.1% of the GDP lost due to soil erosion has a massive impact on the food bill of the more vulnerable members of the population. So basically, what happens is that in India, because there is so much of soil erosion, the fertile soil is going into water, as a result of which the production is getting affected. And because production is getting affected, as a result of which the prices of food is going higher. But if the price of food go higher, then the poor won't be able to afford it. And that's why they were saying that there is a very high bill which has to be paid for those who are not able to afford this, because then you have to give it to them for free. And that is what we call subsidies, right? You can see some more consequences. There are droughts in one of the most important disasters that threaten Sudan. The total area considered as a drought zone in about 69,000 square kilometers, and this area produces 90% of the cultivated food crops, and 85% of firewood. So you can understand that important places across the world are now having effects of pollution and environmental hazards. So soil erosion in Madagascar, deforestation of Madagascar central highland has resulted in widespread soil erosion, which is which in many areas may top 400 tons per hectare per year. For Madagascar, a country that relies on agriculture production for the foundation of its economy, the loss of the soil is especially costly, right? So you can understand these are the various consequences. Now hota kya hai कि guys, we should be aware of these consequences which have been kept at different countries, because such questions might appear in competitive exams where they might ask you what is the consequence of soil erosion in Madagascar, and they'll give you four options, right? Or what is the consequences of some droughts in Sudan. So we should be able to understand what are droughts and why are they happening in Sudan, and the most cultivable land is now getting affected by droughts, right? So in Japan also there's an example. In Japan, especially prone to most natural disasters due to its topography and climate. Among these natural disasters are floods and mudslides, which have caused multiple casualties and fatalities over the decades and even centuries. So you can understand that in Japan, the disasters happen due to topography and climate, and among these natural disasters, floods and mudslides have caused multiple casualties, right? So ये सारे तो consequences हैं. This is what has happened. But in consequences का remedy क्या है? Why is it important to identify unique plants and animals specified to places in order to properly preserve them? ठीक है, ये बहुत important है समझना कि ये सारी चीजें होने की वजह से हम हमारे जो प्लांट्स और एनिमल्स है जो यूनिक है किसी एक स्पेसिफिक जगह के लिए, उनको कैसे हम कंजर्व करके रख सकते हैं, right? Endemic species of plants and animals are found to thrive in specific geographical locations, and they are known as endemic fauna and endemic flora, respectively. ठीक है? Sanctuaries are specially decorated, demarcated areas of land where animals live without a heavy influence of human activity. Okay, so let's understand what are the remedies. So I'll just close this. And now what we are going to see on the earth are different remedies which have been done by different countries in order for conservation of plants and animals. So let's see what has been done in India. So the Indian giant flying squirrel, also called as the large brown flying squirrel or the common giant flying squirrel, is a species of rodent in the family of Securidia. It is capable of gliding flight using the skin membrane stretched between front and hind legs. तो एंडेमिक फ्लोरा जो है वो इंडिया का एंडेमिक फ्लोरा इज द जायंट फ्लाइंग रैट, राइट? Wild mangoes, the wild mango tree, also known as for its scientific name, Mangifera indica, mango tree, are generally native to India. So mango is actually something which Indians have given to the world, right? Arabian tod. So the Arabian tod is a species of tods in the family of Buffonidia. It is endemic to the Arabian Peninsula, and it is found in Oman, Saudi Arabia, and United Arab Emirates and Yemen. So these are a few very interesting, endemic species which we find around the globe. And now, if you see a few more, we can see sanctuaries. Various sanctuaries have been built in multiple, uh, uh, you know, Marane Mauna is a multiple use marine protected area created in 13th of July 2017. It is the largest multiple use marine protected area in the world. Maremona is huge, roughly the size of Mexico. It is super, right? This kind of sanctuaries are now being built in Australia and other places. And there could be a question which could be asked where they ask you, where is this particular sanctuary of Maremona built? Or, what kind of species obtained is native, is a native for India, correct? And they will give you four options. So such kind of competitive exams we have to be ready for. And simulations like this, I'm sure, are already going to be helping you a lot in terms of identifying the various remedies for saving wildlife and also plants. Right? Now, migration. Migration is another topic which is included in this simulation. Migration involves animals having to move, usually due to the change in seasons or over a time, to develop a consistent travel pattern over a long distance to explore the migration path of birds, animals in Africa and North American regions. Correct. So let's see what are the different patterns of migration. So I can see one pattern of migration of animals over here. So you can see that this is Africa. And if I just zoom in onto Africa, you will see what is happening. This, if I click on, it says the wilded beast, the great wildebeest migration is the largest animal migration in the world. Every year, more than 2 million animals, 2 million matlab 20 lakh animals, which include wildebeest, zebras, and gazelles, migrate into a clockwise direction across the ecosystem of the Serengeti, which is basically Tanzania, and the Masai Mara, which is Kenya. Very, very interesting stuff for this. So, in a clockwise manner, they actually migrate in such a way that this is the area which they cover for Africa, right? So you can understand how this kind of migration is happening. There is obviously another very important migration. I think whenever we talk about migration, one of the most crucial migrations is of the flamingos, right? And you will see that this is also a clockwise kind of a migration. And we can see that the snow goose is a small migrating bird, especially white in color with black tips on its wings. These birds nest in the Arctic tundra in the summer and winter in southern US and Mexico. They migrate following the snow line in order to continue to eat along their migration route when in the central flyway. Okay, so basically what to do is जैसे जैसे बर्फ जहां जहां पे होगा उसके पीछे पीछे they will keep on moving so that they will be able to eat on the way throughout the migration. So there are multiple such migrations which keep happening around the world, but these are the two most important ones which we have shown over here through simulation, and also something which is aligned to the textbook which we follow. सो इससे हमें क्या समझ में आया, इससे हमें दो इंपॉर्टेंट चीजें समझ में आई। पहले तो कि सिमुलेशंस से जो टॉपिक्स थोड़े से ड्राई भी हों अगर, दे बिकम वेरी वेरी इंटरेस्टिंग. You get to visualize it much better. I'm sure everyone would now be having much better idea about fire, about flame, different types of flames. Flame का कौन सा वाला पार्ट ज्यादा कंबशन करता है, कौन सा वाला पार्शियल कंबशन करता है, कौन सा कंबशन नहीं करता है. हाउ डू यू डील विथ सब्सटेंसेस विच आर कंबस्टेबल, विच आर नॉट कंबस्टेबल, उसमें भी कौन से फ्यूल हो सकते हैं, कौन से फ्यूल नहीं हो सकते हैं. ये सारा क्लासिफिकेशन जब एक बार हम लोग एक्सपेरिमेंट कर लेते हैं तो उससे इट बिकम्स मच मच क्लियरर. एंड आई थिंक दैट इज द ऑब्जेक्टिव ऑफ ऑल द sessions which we have been taking on weekends. So yeah, I think that is it for today. but we will continue with our simulations on the weekends, on Saturdays and Sundays. Do please share it with your friends who may be interested in taking the subscription for Homi Baba Foundation or for Scholar Lab. Please do instruct them how this is to be accessed, and I'm sure you are going to be having a great week ahead. We are sure that there are holidays which are going to be starting soon, so everyone enjoy holidays. At the same time, please also have your learning and thinking caps on while you do so, so that your holidays can be more productive. So इसी के साथ thank you so much for today's class, and see you in the next class with new topics and something very interesting coming up. Okay, thank you so much, everyone. Have a great day ahead.